La Niña is a fascinating weather phenomena that shapes our planet in unexpected ways. These terms were first used by Peruvian fishermen in the 17th century. They noticed unusually warm or cold ocean temperatures in the Pacific Ocean around Christmas time, which affected fish populations. Over time, scientists identified these as part of a larger climatic pattern known as the Niño-Southern Oscillation, or ENSO. La Niña represents the cold phase of this cycle. With cooler than average sea surface temperatures in the central and eastern Pacific Ocean. Despite the gentle name, La Niña can have significant and far-reaching effects. To understand La Niña, it is essential to first look at trade winds, powerful winds that blow across the Pacific Ocean. During a La Niña event, these trade winds strengthen, pushing warm surface waters westward toward Asia. This allows cooler, nutrient-rich waters to rise along the equator in the eastern Pacific. It's nature's way of turning the thermostat down in one part of the world, but the ripple effect of La Niña is felt globally. La Niña's impacts are dramatic, diverse, and sometimes devastating. In Asia and Australia, it brings heavier rainfall, often leading to flooding, such as the catastrophic floods in Queensland, Australia. During the 2010-2011 La Niña event in the Americas, La Niña is linked to dry conditions in the southern United States and wetter, colder winters in the Pacific Northwest. In South America, La Niña can exacerbate droughts in Brazil and Argentina. Parts of East Africa experience drier conditions, worsening droughts and food insecurity, while Southern Africa often sees increased rainfall. This variability highlights the interconnectedness of our planet's climate systems. Recent research has shed new light on La Niña's broader impacts and its intensification due to climate change. A 2022 study published in Nature Climate Change found that La Niña events are becoming more frequent and prolonged, potentially linked to shifts in global warming patterns. This intensification has amplified extreme weather conditions, particularly in regions already vulnerable to climate variability. For example, prolonged La Niña phases have been associated with more severe flooding in Southeast Asia and droughts in South America, creating economic and humanitarian challenges. Another study highlighted how La Niña events may disrupt global agricultural production by altering precipitation patterns, affecting crops like wheat, corn, and soybeans. These findings emphasize the need for robust climate adaptation strategies to mitigate La Niña's growing impacts on food security and livelihoods worldwide. Some La Niña events have left an indelible mark on history. The 1998-1999 La Niña followed one of the strongest El Niña events on record, bringing wild weather. The 2010-2012 La Niña was another notable event, causing severe flooding in Australia, devastating droughts in the southern United States, and unusual snowfall in parts of Europe. Thanks to advancements in technology, meteorologists can now predict La Niña events months in advance. Satellite data, ocean buoys, and climate models help us understand these complex patterns. However, predicting La Niña's exact impacts remains a challenge, as every event is unique and influenced by other climate factors. While we cannot stop La Niña, we can adapt. Governments, farmers, and businesses worldwide use La Niña forecasts to prepare for its impacts. From managing water resources to planning disaster responses, as individuals, staying informed is key. Understanding these patterns helps us appreciate the complexity of our planet's climate. La Niña is a reminder of nature's incredible power and interconnectedness. From history to science to its far-reaching impacts, this phenomenon touches us all in one way or another. Thanks for joining us on this journey to understand La Niña. Don't forget to like, share, and subscribe for more videos exploring the wonders of our world. Stay curious.